Hello everyone. Today we're going to discuss a new chapter, and the name of the chapter is Winds, Storms and Cyclones. Now we are quite familiar with these terms called winds, storms and cyclones. But what is the relation between them, or how they are interrelated, we can say. So all these things we'll be discussing in this chapter. So let us begin one by one. So first of all, we'll be discussing what are winds. So what are winds? We all know what is wind, but we can not see it, we can only feel it. So the thing that we only can feel, how can we describe it now? So the description of winds goes in this way. The moving air is called wind. Yes, obviously. Air is surrounding us always, but we cannot see the air, can we? No. But we can feel that. So when the air moves, we can feel that movement. And that is nothing but wind. Yes, although winds have different speeds of their movement, and depending on that, the type of the wind also varies. But we'll not go to the types, we'll be just discussing what is wind. So the moving air is called wind. Now it does not have much substance, you cannot see it or hold it, but you can feel its force. Yes, obviously, when the wind blows across our body, we can feel it. But we cannot touch it, or neither we can see it. Now, why this wind blows? That is one question that might arise in our mind. So the wind is the movement of air caused by the uneven heating of the earth by the sun. Yes. Although the sun is, you can say, even across all the places on the earth, but the heating that is caused by the sun rays is uneven. That means sun is visible everywhere on a clear day, but the heating that is caused by the sun rays is uneven. It is not uniform. Some places, say in the polar regions, the sun rays are in a slanting position, as a result of which the heat that is given by the sun rays in those areas is a little bit less, and in the equatorial areas the sun rays fall directly, so as a result their heating is more. So we'll come to that in the next point. So as a result of this uneven heating, there is a movement of air. So the next point will make it clear how this uneven heating actually causes the movement of the air, which is called wind. So differences in the atmospheric pressure generates winds. Yes, due to this uneven heating, there will be some changes in the atmospheric pressure, and as a result of this difference in the atmospheric pressure, it creates or it generates wind. So as I said, at the equator the sun warms the water and the land more than it does at the rest of the globe. That means in the other parts of the globe. So warm equatorial air, it rises higher into the atmosphere, and then it slowly migrates, means it slowly flows towards the polar regions, because in the polar regions the heating that is caused by the sun rays is less, as I said a while ago. So as a result of which, the warm air that rises from the equatorial regions, they go or they flows towards the polar regions. So this is called what? This is called low pressure system. Similarly, at the same time, the cooler or the denser air, that it moves over the earth's surface towards the equatorial region to replace the heated air. That means at the same time, hot air moves from the equatorial regions to the polar regions, and similarly the polar regions, the cold air, it blows or it moves towards the warmer regions, that is the equatorial regions, in order to replace that heated air. So this is called what? This is called the high pressure system. Now winds generally blow from high pressure areas to the low pressure areas. Clear? That means it generally starts blowing from the high pressure areas, that is the, which areas are the high pressure areas? The equatorial areas. From there it starts blowing towards the low pressure areas. So this is the mechanism of winds, you can say. How the winds are generated and how they move across the globe. Now moving on to the next point. It is the great equalizer of the atmosphere, transporting heat, moisture, pollutants and dust to great distances around the globe. So these are some of the main functions of wind. If there is no wind, then our atmospheric pressure would be in an imbalance situation. Also, it helps to transport the heat, even the clouds, you can say, then moisture, pollutants. And as a result of this movement of the winds across the globe, there are different weather changes at different moment or at different times of the year. So as a result of which this weather fluctuates, the climate of the region also fluctuates. So all these things are dependent upon the movement of the wind. So I hope you are now clear with the thing called wind, or the term called wind. So moving on to the next. Next is air exerts pressure. So how does this air exerts pressure? We all know that air exerts pressure. But how to prove that? Or how can we show that air exerts pressure? Obviously by giving some examples. So let us see one activity here. Let us take a tin can with a lid and fill it half with water. We all know what is a tin can. So we have to just fill it half with water. Now you might think, what type of water? Hot water, cold water? No, simple, normal water. Now, after that, what we have to do is, we have to start boiling it for some time. As soon as some bubbles come, then we have to stop boiling, and then we have to close the lid of the tin can. So this is what is going on, you can see. We'll come to this portion later on. This is the tin can. We have started heating. It is filled up. And then after some time, we have to stop heating it and then close the lid of the tin can. This is the lid. Next, what we have to do, we have to pour water over the tin can. Now, as usual, normal water, we have to pour over it in this way. Then what we'll see is that as soon as we pour water over the tin can's shape, before it was cylindrical in shape, now it will gradually get distorted. Like this. As the shape changes. This is called distorted shape. So why does this happen? So the reason is given here, that as soon as the water is poured over the tin can, some steam in the tin can condenses into water, reducing the amount of air inside it. So what happens is that as soon as we pour the water over the tin can, the steam, as we know, it's a hot water now, and we'll pour now cold water. As soon as we pour cold water in it, some steam or evaporation takes place, or the hot water evaporates. And the tin can, then the evaporated steam, or the steam that comes out, it condenses into water. So what happens is that it reduces the amount of air. The air, it is half filled. It was half filled. So half was what? It was air. So due to this steam coming out and then it condenses back into water. So this reduces the amount of air. Half it was air, right? So half of the air now reduces. The volume of air inside that tin can reduces. As a result, it will shrink and the shape gets distorted. Like this. So the pressure of the air inside the can decreases and the pressure of the air exerted from outside the can. As a result, the shape of the can gets distorted. So as soon as we pour this water, what was the amount of or the volume of air which was inside this tin can, half it was filled with air only, half it was filled with water. So that volume gets decreased. Then the volume of air which is surrounding it. So as a result, since this volume is more and this volume is less, so it will exert some pressure from external or from outside. As a result, the shape gets distorted. So what this proves is that air exerts pressure. Clear? So there are also some other activities in which we can find out that air exerts pressure. So what are those activities? Let us see one by one. First one is the very simple, the blowing of the balloon. We all know this thing. So while blowing, why does the shape of the balloon changes? It was small, then it grows bigger and bigger, because the air that is exerted from our mouth, it is giving pressure to the walls of the balloon. As a result, its shape gradually increases. And if you keep on doing it, then at some point the balloon will burst. So why it burst? Because the amount of or the capacity of the air inside the balloon is limited, and after some point it might burst. So we are not concerned about the bursting of the balloon, but why does the shape changes? Because we have given pressure or exerted pressure from our mouth, obviously, to the balloon. So the walls of the balloon gradually increases, or the air inside the balloon gradually increases. So the shape changes. Next one is the pumping of the bicycle. We all know, those who are using cycle, they know that from time to time we have to keep on filling air to the tires or the tubes of the cycle for its smooth running. So why do we do this? Here also, same thing. As soon as the bicyclist pumps with this pumper, this tube inside the tire, it inflates. That means it is filled with air, and as a result, the cycle is again it is able to run on the road. So this is also another example of air exerting pressure. Another is this waving of the flag. Here also we can see why the flag is waving, because air is applying pressure to the different parts of this flag. As a result, the flag gradually starts waving. Another example is the kite. It's a very common example. If you fly a kite, you can feel the pressure of the air exerted on the kite, and this pressure can be felt on the thread itself. If we leave the thread, the air will blow the kite away to a distant place. So this example also shows that air can exert pressure. So I hope you all have understood. There are also other more examples in day-to-day life you can see for yourself. So all this proves that air exerts pressure. So I hope you all have understood today's class. So that's it then for today. Thank you and have a nice day.